Okay, here we are in Notes 21 already, Intro to Polynomials and Polynomial Operations. Let's do some definitions. First of all, a polynomial is a term or the sum of two or more terms that contain variables with whole numbers exponents. Excuse me. The degree of a polynomial is the highest power, or exponent is what it means. The leading coefficient is the coefficient or number in front of the exponent term with the highest, sorry, I just said that all kinds wrong. The leading coefficient of a polynomial is the coefficient in front of the term with the highest power. I'm going to show you on these next four examples, so it'll be a little easier to see. And finally, polynomials are said to be in standard form when the terms are written in order of descending power. That means largest exponent down to the constant if there is one. Okay, what we're going to do in these first four examples is they want us to identify degree and leading coefficient. You know, there's so many words, and it's important that we understand what each one of these mean. Now, when they're talking about the degree, they're talking about the exponent. So let's go through first and find the degree of each one of these polynomials. Now, actually, this first one has a single term, so he is actually called a monomial because he has a single term. Through and identify that. Okay, the second one is called a binomial because he has two terms. Oops. The third one has three pieces in it, so we're going to call him a trinomial because he has three terms. And 1, 2, 3, 4. This one is, we're just going to call him a polynomial. Anything over 2, really, or actually anything over 3 is going to be called a polynomial. 4 or more terms. Actually, all of them can be called, anything over 1 term can be called a polynomial, but typically it's after it's 4 or more. Okay? Now, let's go back and identify first the leading the degree. I'm going to call it D in each one of these. The degree is the power, so I'm going to highlight it in yellow so that you'll know that that's where I'm getting it. Okay, the 4 is the degree. It's the highest exponent. The highest exponent is going to be the degree. This one doesn't have an exponent. What is it if it doesn't show up an exponent? 1. So our degree here will be 1. What is the highest exponent in our third example? 2. So the degree will be 2. And the degree in our polynomial, the largest exponent, 5. And again, I'm going to highlight it. So here in the video, and 2, if you're taking notes, you probably are getting better and better at it. And you know, highlighters and sticky notes are a great idea. So the degree is the largest exponent. Okay? Now, they also want us to identify the leading coefficient. And I'm going to highlight that in this light blue color. The leading coefficient is the number out in front of the highest exponent term. So the 5 in this example, blue spot there. So we're going to say leading coefficient. And for us, it'll be a 5 in this one. Let me write that on all of them. Just like to be organized. It's frustrating. Okay. So let's find the leading coefficient for this one. Well, if there's not a number out in front, what is it? Right, it's just a 1. Okay, for number 3, what is the leading coefficient? Well, it's got a negative out in front, but what number is that translate into? -1. And the leading coefficient for this guy, a 2. The number out in front of the term with the largest exponent is our leading coefficient. And in this case, it was a 2. All right. So hopefully you understand what it means now when they say degree and leading coefficient. Let's look at adding and subtracting polynomials. When you're adding polynomials, the parentheses that are used in these are just there to show us where each term, each term begins and ends. But if they're just being added, those parentheses really aren't necessary. But you always want to check it this way. If you see a number out in front of the parentheses, you would go ahead and distribute it. Because there's nothing but a 1 out in front or nothing in front of that parentheses, I can drop it. There's a plus sign and nothing in front of that parentheses, so we're going to go ahead and just copy all of the terms down. Now this happens anytime that you're adding. When we subtract, it's a little different, and we'll make a big deal about that in just a little bit. But now, at this point, to add and subtract polynomials, once you get rid of all the parentheses, all you're doing is collecting like terms. I've got 2 squared terms, so 9 of those and 3 of those add up to 12 of those. Next, we'll look at our x's. We have a negative 1x and a positive 4x, which add up to a positive 3x. Next, we have a 5 and a negative 2. Both of those are just constants. 5 and negative 2 add up to 3. And that's what it looks like when you add polynomials. Let's do it on this next one. Again, this parentheses doesn't have anything in front of it, so I'm going to go ahead and copy it down and take everything out of that parentheses. There isn't anything to distribute. Because there's a plus sign in front of this and a 1, nothing's going to change. So I'm going to go ahead and bring down the plus sign and then just copy the second polynomial down. Now, let's combine like terms. We have a 4z to the 4th and a negative 2z to the 4th. So 4 and negative 2 of those make 2 of those. Next, we're going to deal with the 3rd degree terms. Notice I use a little marking technique. It's really helpful to keep track and make sure you use all of the pieces. And since we did the 4th degree terms, we're going to do the 3rd degrees now. A negative 2 of those and 6 of those make 4 of those. Now, in looking to see which ones come next, I've got one 2nd degree term over here. So I'm going to mark him. But there aren't any others. That's okay. That just makes it easier. You don't have to combine it with anything. Next, we'll take our z term. There's only one of those, so that one would go next. And then finally, we've got a negative 5 and a positive 4. Those two constants need to be combined because they're like. Negative 5 plus 4 is negative 1. And that's it. Now this is called descending order or standard form for a polynomial. We've got the 4th degree terms first, 3rd degrees, 2nd degrees, 1st degree, and plain constant last. All right, and let's continue. I think we can do another one or two in this video. Now, these are subtraction. I want you to put a star by these so when you're learning how to do them, you kind of like bring to mind, I must do something with the negative. Now, they start exactly the same way. The first parentheses doesn't have anything in, to change it or distribute in, so we're just going to copy them down. And I don't bring the negative down. The negative is going to have to be distributed. This is where that is different. And it's like having a negative 1, and you're going to distribute it onto each piece in the second parentheses, like this. Negative 1 times 2x cubed is negative 2x cubed. Negative 1 times 12x squared is going to be a negative 12x squared. A negative times a negative x is a positive x. And a negative 1 times a positive 1 is a minus 1. Once you get all of the negative in front of that second parentheses distributed, you can combine like terms. But again, we want descending order. So you're going to start with the third degree terms first because they've got the highest exponents. 7 of those and negative 2 of those combine to make 5 of those. Next, we're going to hit the squared terms. And again, you can use any kind of marking technique that you want. This one's pretty cool. I've been using it for about 40 years. Negative 3 of those and negative 12 of those added together combined make negative 15 of those. Next, we can do our plain x terms. I've got 2 x's and 1 x, which make 3 x's when I combine them. And finally, we've got a constant 8 and a constant negative 1. When I add the 8 and the negative 1 together, I get plus 7. Let's finish one more. All right, again, first parentheses doesn't require anything, so I'm going to go ahead and bring it down. Remember, when you have terms that have multiple letters, multiple variables in them, make sure that you put the letters in alphabetical order if they're not already there. This is a perfect example of why. Because it's a subtraction problem, I'm going to mark it so I don't forget. I'm going to have to distribute that negative onto the 3 pieces inside the second parentheses. A negative times a negative 2 of those is going to be a positive 2x squared y. A negative 1 times a positive 4 of those is going to make a negative 4x squared y squared. A negative 1 times 6 of those is going to be a negative 6 of those. And really the only thing that changes sign is that lead coefficient. All right, now when you have stuff that looks like this, it's kind of hard to know what order they're in. So my rule of thumb is always just go left to right. There's an x squared y. There's an x squared y. Those are the only ones that have x squared y. So 9 of them and 2 of them makes 11 x squared y's. Next, let's look for terms that have an x squared and a y squared. He does, and he does. 6 of them and minus 4 of them make 2 of those x squared y squares. And then finally, we've got xy squares on both of these, so we're going to combine those. Negative 3 of them and negative 6 of them makes a negative 9 of those. Notice the variables didn't change. And it's really hard to put it in order, so don't feel bad. My rule of thumb is when you've got a lot of different terms with lots of different exponents, go left to right. And I'll see you in the next video to finish this section off.